Fundamental theorem of arithmetic. Fundamental theorem of arithmetic tells us that every composite number can be expressed as a unique product of prime numbers. There's only one way to break down each composite number into a product of primes. This unique product is called the prime factorization of the number. And the process we go through finding that prime factorization is called factoring. Now, one method I like to use to factor out a number is to pull out factors, pull out prime numbers at starting with 2 until I've broken the number down as far as it'll go. For example, with the number 36, I look at it and see that 2 will go into it. 36 is 2 times 18. Now I look at the 18. 2 will go into that. 2 times 9 is 18. Now I look at the 9. 2 won't go into 9, but 3 will, so I'll go up to my next factor, which is 3. And 9 is 3 times 3. And we've worked our way down to where we have a prime number at the end. These four numbers, 2 times 2 times 3 times 3, that is the prime factorization of 36. A more common way of writing this is to say that this is 2 squared times 3 squared. Now, I know that some of you are wanting to break it up as 4 and 9, and then you split each of these up, and that works fine. I just like to bring out one factor at a time myself. Whatever works for you is fine. 525. Well, let's look at this one. 2 won't go into it. We know that. Will 3? Well, 5 plus 2 plus 5 is 12. 3 will go into 12, so 3 will go into 525. And 3 times 100, let's do some long division. 3 will go into 5 once. Subtract, drop down the 2. 3 will go into 22 7 times. 7 times 3 is 21. Subtract, bring down the 1. 3 will go into 15 5 times. And we get 3 times 1, 75. Now I could add up these digits to see if 3 will go into them. But remember back here when we added the 525 together, we got a 12. And since 9 won't go into 12, we're not going to be able to pull two separate 3's out of this number, because 9 is a pair of 3's. So we'll look at 175. We already know that the 2's won't go in. We've used all our 3's. So we'll look at 5. And 175 is 5 times. 5 will go into 15 3 times. 5 times 35. We'll look at this and see if 5 will go in again, and it will. We get 5 times 7, and we've worked our way down to a prime number. So 525 is going to be the product of these last numbers, the ends of all these branches, 3 times 5 times 5 times 7, or 3 times 5 squared times 7. That is the prime factorization of 525. Our next idea that we're going to work on is that of the greatest common divisor. The greatest common divisor, or the GCD, of two numbers is the largest number that is a divisor of both numbers. For example, if we look at the GCD of 18 and 24, we're looking for the largest number that is a factor of each of these two that is a divisor of each of these two numbers. So if we look at all the numbers that go into 18, 1, 2, 3, 6, 9, 18, and all the factors, the divisors of 24, 1, 2, 3, 4, 6, 8, 12, 24, we see that 6 is the largest number that appears on both lists. Now we can use prime factorization to find the greatest common divisor of larger numbers. What we'll do is find the prime factorization of each number, and we'll look at the different factors and we'll pick the smallest quantity of each factor that appears in both factorizations, in both numbers. So let's look for the factorization GCD of 240 and 525. Now I'm going to cheat and use the fact that we just did 525, and we found that that was 3 times 5 squared times 7. So we just need to figure out the factorization of 240. 2 times 120. This is a weakness of using my method when you have lots of factors. That's 2 times 60, which is 2 times 30, which is 2 times 15, which is 3 times 5. And I have 1, 2, 3, 4 factors of 2, so that's 2 to the 4th times 3 times 5. So 240 is going to be 2 to the 4th times 3 times 5. So my factors that I've got are 2, 3, 5, and 7. And the GCD is going to be the smallest number of each of these factors that appear in both places. Well, I've got 2's down here in 240, but I don't have any up here, so I'm not going to put any 2's in my GCD. I have a 3 here, and I also have a 3 here. So there is a 3 that is common between these two factorizations. I have a 5. Now this is 5 to the 1st. I'm just too lazy to write the 1. I have 1 factor of 5 down here. I have 2 factors of 5 up here. Well, I'm going to select the smaller quantity, or the smaller number of 5's, and since I have 1 in each place, I just have an extra 1 up here. I'll just put 1 in my greatest common divisor. And finally we have a 7 in the 525, but there's not one in the 240, so we'll ignore the 7, and we end up with a greatest common divisor of 3 times 5 is 15. Least common multiple. The least common multiple of two numbers is the smallest numbers for which both numbers are a factor. We're looking at larger numbers now. For example, the same two numbers, 18 and 24, have a least common multiple of 72, because 18 is a factor of 72 and 24 is also a factor of 72. And when we look at these multiples, 72 is the smallest, the least common multiple. Now notice that 144 is also a common multiple, but we're looking for the least common multiple. So that's why we're going with the 72. Since it comes up at this time, it's probably no surprise that we can use prime factorization to find the least common multiple of large numbers. We're going to factor each number just like we did before, and except this time we're going to select the largest quantity of each factor that appears in either number. So going back to our 240 and 525, again, we'll add a little bit of laziness. 240, I'm not going to refactor it. 2 to the 4th times 3 times 5. 525 is 3 times 5 squared times 7. And so our least common multiple is going to be, let's see, we've got 2 to the 4th up here. We don't have any 2's down here. We're going to use the larger quantity, so we're going to use 4 of them. So we have 2 to the 4th in our least common multiple. I've got a 3 up here. I also have a 3 down here. So they both have 1, so the largest number that appears in either place is one of them. I've got 1 5 up here. I've got 2 5's down here, so the larger number that shows up somewhere are the 2 5's in the bottom, so we'll add a 5 squared into this as a factor. And finally we have a 7 in the 525. We don't have any 7's in the 240, so the larger number that appears anywhere is in the 525. If I multiply this all out together, let's see, we get 16 times 3 times 25 times 7. That gives us 8,400. So this is the smallest number that is divisible by 240, and it's divisible by 525. Oops, yeah.